Okay, welcome back. So right now we're going to talk about writing inequalities. Hopefully this is a little bit of a review for you, but the reason I'm doing this is because it's going to help us understand how to find domain and range of a continuous graph or of line segments of some sort that both have an x-axis and a y-axis. So just for this part, we're just going to focus on the x-axis. And since the x-axis is the horizontal axis, all of my number lines are going to go like this. So now, if I just have a number line and I put a dot on the number line and I want to represent what this is, well, this is just x is equal to 3, right? So if I am now representing something that looks like this, where I have a closed dot on 3, but I shade everything to the right of 3, well, these are all the numbers that are bigger than 3, but I also want it to be equal to 3 because I have a closed dot. So we would represent this as x is greater than or equal to 3. Now, if I were doing this as a domain, I would write it x such that. So I would add this x such that here, and I would put it in set notation, okay? So now the next one, closed dot on 3, which means it's equal to 3, but it's shaded to the left. So these are all the numbers that are less than 3. So we would say that x is less than or equal to 3. And if I were asked to write it as a domain, you might see it written as x such that x is less than or equal to 3. The next one has an open dot on 3, and you're shading everything to the right. Now, because it's an open dot means that 3 is not part of the solution or the domain. So we leave off the little line on the inequality symbol, and it's just x is greater than 3. If I wanted to write it as a domain, it might be written as x such that x is greater than 3. Now the next one, open dot on 3 and shade it to the left, so now it would be x is less than 3. And so it would be x such that x is less than 3. Okay, now stop the video and try the next 4 problems. All right, so here are the answers to the next 4. Notice that I did go ahead and I used the set notation with x such that. But if you left that part off, go ahead and just put it in now, and let's just practice doing that, because when we're doing domain and range, you're going to actually express it in that way. Notice that A and C have the little line on it, and B and D do not, because these are open dots. Also, you might want to notice that if you put your variable first, the inequality symbol is going in the same direction as your arrow, right? So since this one's shaded to the left, the arrow is going that way. This one, the arrow is going this way. This one's the arrow is going this way. This one, the arrow is going this way. And if you notice, it is the same here as well. Now that little trick only works if you're writing your variable first. All right, now let's take a look at these next 4. These next 4 are called compound inequalities, and the reason they're compound inequalities is because there's 2 things going on at once. So if you take a look, this first one is pretty simple. If you look, you've got x here is going to be less than -2, or x is going to be greater than 5. And so the way that we would write this is we would write, if I was writing it as a domain, I would start with x such that, and then I would take this part of the graph, which would be x is less than -2, or then I would take this graph and make it x is greater than 5. So basically, this would cover all of the x values, or every number on the number line, except for this section right here in the middle. All right, now, number 2 is a little bit different. Number 2, they're going towards each other, right? So you've got this closed dot on -2 going to the right, and this open dot on 5 going to the left. So now, just bear with me for a second. I'm just going to write this part of the inequality. This is saying that x is greater than or equal to -2. But this part right here is saying x is less than 5. Now, because they're going into each other, we can do a combined notation. I call it an in-between notation, because basically, isn't x in between -2 and +5? Well, let me show you what this is going to look like. So I'm going to start by writing x such that, and we're not going to say x, we're going to start with, well, -2. So imagine if I took this inequality and I flipped it. If I wrote -2 first, well, then I could say that as -2 is less than or equal to x. So I would flip the sign, and then I can say, well, I can then take this part of it and call it x is less than 5. And so then I would close my brackets. So let me tell you what this means. If you read it starting in the middle, if you read it to the off to the left and then off over to the right, this is saying that x is between -2 but can equal -2. So x is being eaten by this symbol, so x is bigger than -2, but less than 5. So whenever you have it, this is called an AND graph. Whenever you have the two going towards each other, then you would write a combined one. When you have two of them going in opposite directions, this would be an OR graph, so you have to write them separately. Let's go ahead and try 3 and 4, and then you can try some on your own. So for 3, you've got two different things going on. So you're going to start with x such that, and then we're going to write our answer. So again, this one would be x is less than or equal to -2, or, and it would be or because they're going in opposite directions, x is greater than 5, just like that. All right? Number 4, again, they're going towards each other, so we're going to combine it. So we're going to say, start off with the bracket, x such that. And what we're doing is we're going to say that x is basically in between -2 and 5. And the symbol we're going to use here for this, x is actually, this x in the middle, actually has to be bigger than -2, but equal to. But x is smaller than 5. And so what you would write is x such that -2 is less than or equal to x, less than or equal to x, which is less than 5. So if you think about it, x is going to be in between -2 and 5. Now, the cool thing about these combined notations is that the symbols in here are always going to be less than symbols if you're going from least to greatest. If I were to flip it and put this first, then the symbols would be greater than symbols. So if this is all confused, you're like basically reading this first part backwards and then forwards, backwards and forwards. All right, so now stop the video and try the whole other side of the paper by yourself, and then tune back in to see if you've got them right. So here are the answers to 5, 6, 7, and 8. Notice they're all very similar because they're all the in-between kind. Notice I went from least to greatest, and all of my symbols are less than symbols, and I just have to decide if there's a line or not a line based on if I have a closed dot or an open dot. And here are your answers to the next several. Notice 9, 10, 11, and 12, these are all OR graphs, so you have to list them separately, but these are combined. And so here x is between 0 and 5, here x is between 2 and 9. All right, that's all for this video. Good luck with everything.